Hi folks, we're going to take a look at number 13 from page 392. So they tell us that if log base b of a is equal to c and log base y of b is also equal to c, then they want us to show that this equality is also true. Okay, so first thing to keep in mind is that we're given that these two things are true. We can't assume that this one is true. So similar to solving or proving an identity, what we're going to do is we're only going to work with one side at a time. So since all my information is given in terms of logarithms, I think I'm going to work with the left-hand side. Okay, so we'll start with the left-hand side of this equation, which is log base a of y. And I'm going to need to try to incorporate the information that I'm given. So I notice here that they give me some information about a logarithm, except the base is different. Okay, and this is a trick that comes in pretty handy where you're working with one base, but the information is given in terms of another base to do a change of base. So I'm just going to apply my change of base formula. So let's write this expression in terms of log base b. So the change of base formula is the logarithm, okay, of the original input, so in this case y, divided by the logarithm of the original base, which in this case is a. Okay, so I'm switching this into log base b. Now this is useful because I see that log base b of a is in my denominator, and they tell me what log base b of a is equal to. It's equal to c, and I know my final answer should contain some c's. Okay, so we've gotten part of the way there. Okay, so now I still have a logarithm in my expression, but the second piece of information is given with respect to yet another base, y. So I'm going to do the same thing. I'm going to take this logarithm that I have and change it from base b to base y and see what happens. Okay, so let's apply the formula again. So log, okay, base y of the original input, which was y, over log base y of the original base, which was b. Okay, and then of course all of this is divided by c. Okay, and I see something very nice that's happening because log base y of b is exactly that other piece of information they gave me, which is equal to c. And furthermore, hey, what's log base y of y? Well, that's just equal to 1. So what we have here is we have 1 over c divided by c. And now I'm just going to do a little bit of algebra here. So remember, dividing fractions is the same as multiplying by the reciprocal of the what I'm dividing by. So what's the reciprocal of c? 1 over c. So I'm just left with 1 over c squared, which of course is equal to c to the negative 2, which is just equal to my right-hand side. Okay, so I've shown that left-hand side is equal to the right-hand side, which is what I wanted to do. Okay, so just to recap here, and we see that the big idea out of this is using this change of base formula, is I'm trying to express this logarithmic expression differently, and the information I'm given involves logarithms of different bases, so that's why it makes sense to incorporate the change of base formula. In this case here, I needed to do it 2 times in order to use both pieces of information. Okay, that's it for this one.